Now in this lecture, we again use more examples on differentiation under integral sign. The question is, prove that integration of x to the power a minus 1 upon log x under the limit 0 to 1 with respect to x, which is equal to log a plus 1. Let I of a is equal to integration of x to the power a minus 1 upon log x under the limit 0 to 1 with respect to x. Now using DUIS rule number 1. Why? Because here the limit of the integration or constant, it is 0 and 1, which is free from a. So we can apply the differentiation under integral sign rule number 1. Just differentiating left hand side and right hand side. So derivative of I a, which is given by di upon dA, which is equal to, now we have to differentiate this using the integral sign duis. So it gives us integration under the limit 0 to 1 uh, and partial derivative of x to the power a minus 1 upon log x with respect to a whole dx. Now if you want to find out the partial derivative of x to the power a minus 1 upon log x is free from a, so we can take outside of this derivative. So we can write down integration of uh, under the limit 0 to 1 upon log x. We have to first write 1 upon log x, and derivative of x to the power a with respect to a is x to the power a log x. Like that, we know that what is the derivative of a to the power x with respect to x? It is nothing but a to the power x log a. So here we want to find out the derivative of x to the power a with respect to a. So this will be x to the power a and log x. So now this is what? So this log x and the log x will cancel. We have integration of x to the power a under the limit 0 to 1 with respect to x. Now, what is the integration of x to the power a? It is x to the power a plus 1 upon a plus 1 under the limit 0 to 1. Now, if you put the upper limit, x to the power 1 plus a is 1 and upon a plus 1, and if you put the lower limit 0, so ultimately it will become 0. So the value is 1 upon a plus 1. Hence, dA, which is equal to 1 upon a plus 1. This is variable separable differential equation. Separating variables and integrating, we get integration of di, which is equal to integration of dA upon 1 plus a plus integrating constant c, where c is an integrating constant. Now, what is the integration of d of I? It is I of a, which is equal to integration of 1 upon a plus 1 is log a plus 1 plus c. Let us give it equation number 2. Now we have to calculate the value of c from equation number 1 and equation number 2. Putting a equal to 0 in 1 and 2, we have. So from equation number 1, we have I of 0 is equal to integration of x to the power 0 minus 1 upon log x under the limit 0 to 1 with respect to x. Now x to the power 0 is 1, so 1 minus 1 is 0. So this total, what is the integration of 0 upon log x, which gives us 0. So integration of this total term is 0. So I of 0 is equal to 0. This is from the first equation. From the second equation, I of 0 equal to log 0 plus 1 plus c. But we know that log 1, which is also 0. So c is equal to I of 0, but I of 0 is 0. So ultimately we have the value of c is 0. Hence 2 becomes I of a is equal to log a plus 1, which gives us integration of x to the power a minus 1 upon log x under the limit 0 to 1 with respect to x, which is equal to log a plus 1. This is the desired result, hence proved. Thank you.